Welcome to another unit in the workbook statistics, this time with an exercise focusing on the so-called homogeneity test. Let's take a look at our exercise. Here we have, in Düsseldorf and in Cologne, people are surveyed with regard to the highest educational degree they have. The result is the distribution in the table below. And we get for both cities how many people list university, A-levels, or neither of the two as the highest educational degree. Our task now, use a suitable test to check whether significant differences exist between the distribution in the two cities. Consider that the margin of error of 5% is deemed acceptable. Well, whenever we have to compare two more or less frequency tables, that's a good idea to use the homogeneity test here, because this tests whether both of those samples share a common distribution. Well, let's do this. So to actually apply the homogeneity test, in the first step, we need so-called expected frequencies. To get the expected frequencies, I'm just going to copy the table from before, and I'm going to calculate the overall sums for both samples, so for the Cologne and the Düsseldorf sample, by simply adding up all these numbers, giving me here 500 and here 600 observations. Then in the next step, I'm going to calculate the theoretical joint distribution. So under the assumption that they share a common distribution, what would this distribution actually look like? And how do we get these numbers? Well, I'm going to add up for university level both values for Cologne and Düsseldorf, giving me 260. Those 260 I'm going to divide by the sum of the two sums, so by 1100. So if I divide 260 by 1100, I will get 0.2364. Then I'm going to do the same thing for the A-levels. 150 plus 210 is like 360 divided by 1100, giving me this value. Finally, 230 plus 250, giving me 480 divided by 1100, gives me this percentage value for the neither category. So that was the first main step. In the second, I'm going to use this distribution here to calculate the absolute expected values for both samples. How am I going to do this? I'm just going to multiply these probabilities with the sum for Cologne, giving me the three values for Cologne, and with the Düsseldorf values, giving me the three values for Düsseldorf. So here I have the two results for Cologne and Düsseldorf. First one I get if I multiply 0.2364 times 500, that one. Then 0.3273 times 500, that one. 0.4364 times 500, that one. I'm going to do this, as I did here for Cologne, similarly for Düsseldorf. I'm just going to multiply all three values with 600, yielding me these values for Düsseldorf. If I want to know whether I did this correctly, I can add the sum of the expected values for Cologne and the sum for the expected values for Düsseldorf. Because in the end, I have to get exactly the same results here as I got here. Once I check whether I did this correctly, I can start calculating my chi-square test statistic. For this, I'm just going to compare them pairwise. Actual frequency, expected frequency. Actual frequency, expected frequency. So in total, in this case, I have 6 parts where I need to calculate something, 6 comparisons I have to perform. Well, with chi-square, comparison means I'm going to take the actual value, subtract the expected value. That's here, actual minus expected. Square the result and divide this by the expected value. I'm going to do this for all 6 possible outcomes. So the second one is for Düsseldorf and University, then I have Cologne and A-levels, Düsseldorf and A-levels, and so forth. If I calculate the result, in this case, I get 3.3079. So that's my test statistic. And this test statistic I'm going to compare with a reference value I get from the table. So next step would be to actually get this reference value. That's what I'm doing here. The reference value for a homogeneity test can be determined as chi squared I minus 1, 1 minus alpha. The I in this case is the number of categories, or as with us, we have 3 different qualification levels, so 3 categories, so the I in this case is 3. 3 minus 1 gives me this 2 in this case. Then I have the alpha. The alpha is the margin of error. Margin of error in the exercise text it said should be 5%. So I'm calculating 1 minus 0.05, giving me 0.95. So in the table for the chi squared distribution, I'm going to look up the value chi squared to 0.95. There I'm finding a value of 5.9915. So I'm using this value in my actual test or test decision to compare it with the test statistic. Here I see that the reference value is larger than the test statistic. And whenever this is the case, I cannot reject my H0 hypothesis. The H0 in the case of a homogeneity test is that both samples share the common distribution. Well, applied to our situation, we can assume that in both cities I have comparable educational structures, or it cannot be assumed that in both cities there are different educational structures. Well, that concludes this exercise. I hope you enjoyed it. I say goodbye and see you next time.